Our next presenter is Justin Garwood. Justin is an environmental scientist with CDFW's Northern Region Fisheries, where he has worked on landscape level population monitoring for coastal salmonids and Klamath Range amphibians over the past 20 years to inform species recovery. Justin grew up in Trinity County and enjoys backpacking, fishing, and rafting with his family and being a mentor to emerging field biologists. He holds a BS in fisheries and an MS in wildlife at Cal Poly Humboldt and is co-editor of the recent book, The Klamath Mountains and Natural History. And full disclosure, Justin did not pay me to say this, nor did we collude on what I'm about to say. But if you love this watershed, you need to read this book. It is a labor of love. It is full of local knowledge. And it's just beautiful. And if you want to take a look at it, I can lend it out to you guys. It encompasses Scott Valley and the lands that we live. So please help me in welcoming Justin Garwood.
I didn't make a dime on that book. I don't know. I did it for free. Anyways, I'm going to give you an update today about what we've been doing the last 4 or 5 years in the High Mountain Lakes, dealing with some management issues. I want to introduce myself. I'm here. I want you guys to see my face, what we do. Braden was on this project for a few years. He's moved on to be a Eel River district fisheries biologist, so he got a permanent job. And Amanda has filled in his role this year. And these folks really helped me get these field crews out the door and plan the season. We've had over 40 seasonal staff from 21 to 24. I want to stop the rumors that the PCT hikers you see driving government rigs in Etna, those are not PCT hikers. They're actually the High Mountain Lakes team, and they really want a hamburger. So they work really hard. Just an outline. I'm going to give an overview on what mountain habitats we're talking about in the Klamath Mountains here. The unique communities and biodiversity that they host, how a new fishery was born in this region, and what could go wrong with that fishery over time. Measuring ecological change after we've shifted some policy on fish stocking in high mountain lakes, and then prioritizing fishery lakes and areas that are of conservation need to protect native sensitive fauna or flora, or fauna, I mean. And then we have some targeted restoration and promoting responsible fisheries ahead. So the Klamath Mountains are here on the right. Here we are in the Scott Valley. They are one of the most biodiverse temperate mountain ranges on the planet. It's because we have really diverse geology, topography, coastal position, and latitude make this place a melting pot for diversity. The blue represents elevations above 5,000 feet. So we have this high vertical relief that creates a snow-fed system. And during the Pleistocene, which was about 2 million years long, we had 4 glacial substages that created all these beautiful high mountain lakes, meadows, and ponds that we enjoy to recreate in. And you can see here's a profile of that from south to north with the highest mountaintops through the range. And you can see where the vast majority of lakes are above glacial elevations where the landscape was glacial characterized. There's less than 50 natural lakes in lower elevations, which are created more by landslides, different processes. But these are relatively young systems. The Pleistocene ended about 10,000 years ago, but it created all these beautiful lakes of all shapes and sizes throughout the Klamath Mountains. They're just a stunning landscape with tons of diversity of features. We have deep, steep lakes to these shallow lakes that have lots of nice lacustrine meadow systems around them. And there's thousands of ponds. What we were showing was lakes. There's hundreds of lakes, but there's thousands of ponds that come in all shapes and sizes and different hydrology. And then we have thousands of meadow systems that Megan was bringing up, these fens that are really important storages for water, and they promote biodiversity. So after these habitats became available, roughly 10,000 years ago, things moved in. And here's two great examples of species that came in from the Cascades after that ice age and populated these high elevation lakes, ponds and meadows. The long-toed salamander and the Cascades frog, these are high elevation specialists. They don't, except for the long-toed salamander, actually occurs in the Scott Valley, and some people have found them in their sprinkler boxes. If anybody sees any, I'm really curious to hear about that. Betsy has found them on her property too. But the Cascades frog is really a high elevation frog that lives in these very high elevation systems above 4,000 feet. And these lake systems are what we think of biologically as very simple ecosystems because they're under snow and ice for 6-7 months out of the year. They have very small watersheds above them that are not as forested. So the nutrients that input into these lakes is very low typically. So we think of them as mesotrophic and oligotrophic, meaning they don't have the diversity we see down lower. So you can see we have primary consumers, the zooplankton, and they feed aquatic invertebrates, which that nutrients comes out of the lake and feeds terrestrial species, but also these mid-level consumers, frogs and salamanders, to which a garter snake is actually the top predator in one of these systems. Top aquatic predator, which down low, you'd think it's a river otter. That's the river otter in high mountain lakes. And amphibians, despite having been this place of this relatively low productivity, they have a lot of young, right? They have this, a lot of things to eat them, right? They are the tater tot out there in the ponds. So you can see there's tons of them, and we just need some to survive and become adults to breed. So they are a great food resource seasonally for lots of different species. Let's talk about stocking. Just so you know, like all these high mountain lakes were historically fishless, right? The fish could not migrate into them after the ice age. You've climbed up to these lakes, you know what I'm talking about. There's waterfall after waterfall. It's really, really remote and high elevation. So CFW started stocking this in 1912. That was the first kind of stocking that I've found in our records. And through the 1940s, we stocked about 80 lakes with mules and vehicles. That's about what we could get to. But after World War II ended, we had a lot of great airline pilots from that war, and they had some time on their hands and things, and they were really resourceful, and they stocked the vast majority of lakes after 1950. You can see that dramatic rise to the point where 91% of the lakes were stocked, and by the time the Wilderness Act of '64 passed, these lakes were all seeded with fish. So pretty dramatic history through time. This is what we think of as good intentions, unintended consequences over time, that we've come to find out. We love fish, right? We wanted to fish for them. So we put them everywhere. Here's the 3 species of fish. Brook trout here are from the eastern North America. And you can see what's really interesting about brook trout is they can spawn inside the lakes. They don't need streams to spawn. So they're very successful. And you'll see that in some of our data slides. And they were stocked in at least 286 lakes. We stopped stocking them in 2016. We no longer carry the brood stock in California because they are non-native to the region. And our stocking EIR does not allow us to use that brood stock anymore. But they're doing fine. They're everywhere on their own. Brown trout, we stocked them a lot less. They're another fish that's from native to Europe, North Africa, and Western Asia. They were stocked in much fewer lakes, but they are holding on in places like Cliff and Campbell. They still are there because they were able to spawn in some of those streams where they can get access to spawning grounds. Rainbow trout is the fish that we stock today, or at least that's the one we're distributing throughout the Sierra, the Cascades, and the Klamath Mountains because it's regionally native. And it requires streams to spawn. It's very sensitive in high mountain lakes to survival. So it's kind of a dilemma because it didn't adapt to living in high mountain lakes. So even though it's right up the hill from where they are doing where steelhead are, it's a much different challenge for that animal to persist and that at least reproduce. But we stock them in a lot of places, about over 240 lakes. So fish were put in these systems for the sole purpose of angling, recreation. We're going to catch some fish. We're going to eat some fish. You know, if you look at the ecosystem, that's not as simple as it is. What happens is the fish got to eat, and they eat lots of stuff, including these primary consumers, but also, you know, frogs and salamanders. And then stuff comes in to feed on them. You know, if you've seen bald eagles and osprey in high mountain lakes, they're there because the fish are there. So they come into the system, kingfishers. And then we have species that are fish eaters, like down low in the Scott Valley. This aquatic garter snake is a very effective fish hunter. It actually has behavior where it flicks its tongue on the surface of the water and it catches fish. It lures them in and catches them. So it is really lives hand in hand with salmonids, and it's just adapted to that. We find them in the high mountain lakes now. They're pretty much widespread where fish are. And we think we've also seen river otters up in high mountain lakes. I have quite a few records of that. If anybody has any more, I would love to have those records. We published a paper on the river otters in the high mountain lakes across California. It's in the Sierra too. And we found them primarily, we analyzed their scat, and they're eating lots of fish, but they're also eating frogs. So we call those cascading effects, where these species are actually feeding on native fauna, even though the fish is a prey source for them. They're being subsidized by trout, and then they're having a greater effect on native species in some places. I'm going to focus on Cascades frogs today. There's others, you know, it's one of the richest amphibian diversity, and the only place that has higher amphibian diversity from the Klamath Mountains is the Southern Appalachian. So it's a really special place for amphibian diversity. This frog is a high elevation specialist. It breeds in lakes and ponds. And it's long lived. I have a frog that we caught 2 years ago in my long-term site that's at least 18 years old. I marked it in 2003, back when I was like way younger. So major threats. It's a species of special concern. It got petitioned for listing in California in 2017. It's taken forever. It's still in status review. I haven't received the draft of that yet, but it's likely going to make the commission by this year to make a decision if this animal is going to get listed by the state. Major threats: invasive fishes. It's naive to fish. It didn't really coexist with fish. Habitat loss through climate change. We have all these droughts in a row. The habitats that are outside of where fish live are drying up more, so they don't have as much options. And then disease. You've probably all heard about chytrid fungus. It's a global pandemic for amphibians. There's really not much we can do about that, and there's not much we can do about climate change. But we can do something about fish, because fish, if we have fish in all the perennial waters, they're widespread. You can see that pond in the upper corner there. That's a wet year. Looking at a dry year, what happens to that pond? Frogs breed in there in a wet year, but in dry years, we have more and more dry years. The fish are taking up all of the perennial water, the climate resistant or resilient habitat. We see this firsthand. Last summer, we have a restoration site up in Middle Boulder Lake Basin. It's a small pond, you can see with the trout. We pulled these fish out as part of that restoration. We inspected their stomachs. Those frogs were born in the lake, the pond right next to it. And they're eating them when they move over to the fish pond. So we're seeing that real world. It's not just some idea. This is happening on the landscape. Looking at that stocking graph, we're going to flip it on its end, and cessation, right? This is stopping stocking through time. You can see the big airplane stocking event. After that year, they toned it down. Maybe they didn't have the funding or the pilots, but 20% stopped stocking after that. We did our first, it was a collaborative between the Forest Service and CDFW doing our first amphibian and fish census to get a check on the landscape back in 2000. That's me 24 years ago. I was a tech on that project. So it's come full circle for me. I'm doing 2.0 24 years later. We got sued for our stocking practices back in the early 2000s. That we had to create an EIR for that. And you can see once we got sued, we stopped stocking them dramatically because we're in the hot seat for not accounting for native sensitive species. And then by the time 2016 rolled around, we were only stocking rainbow trout. And once Cascades frog were petitioned, we have to treat it like it's listed. We stopped stocking in 2019. We just stopped. There's a few places we stock still in the Klamaths, but by and large, we had this big experiment out there. What happened when we stopped stocking? We got our grant to actually measure that. So our goal is to revisit that same footprint that we did 20 years ago. We call it High Mountain Lakes 2.0. And I drew 380 basins where Cascades frog breeding sites exist throughout the Klamath Mountains. You can see there. And we did a sample design throughout those 380 basins. So we wanted to look across the range. And we also wanted to survey for non-native fish in lakes. These are all the lakes. They're widespread throughout the upper Klamaths. So how are the fish doing once we stop stocking, and what are their distributions relative to the past? And then we want to compare those survey results to the effort 20 years ago, and then we want to use all that data to manage forward. Our methods, we basically did visual encounter surveys for amphibians in those basins, not just the lakes, but all the meadows and ponds around them. We census the habitat, and we gill netted fish to get it demography information, catch per unit effort, species composition, size class distribution, all those things you can get from sampling a population. We didn't take a fish out, we just took a sample of fish. We've surveyed 1,400 sites across 224 of those basins. We've had, crews of 12 for 3 summers. They get a lot done. And we got 550 sites that we can compare between the 2 periods, and we netted over 261 for trout. We only have 26 left, and we'll have a complete census of all the historic lakes stocked in the Klamaths by the end of the summer, which I'm really excited about. The sample lakes or basins are all the green. The ones we didn't sample are in brown. We use a spatially structured sampling design to make sure we get good coverage across the area. This is just raw data, but we are currently in the analysis mode. The take-home messages, we've seen about a 17% decline in Cascades frog site distribution. But the Trinity Alps are holding strong for whatever reason. They're not showing a decline, whereas these other smaller sub-ranges, we are seeing, fewer frogs on the landscape overall. And where we do see frogs, we're seeing about a 50% reduction in the number we see. So you can see Trinity Alps are holding strong in their counts too, but these other basins are, there's fewer and it's consistent. And I have some ideas about that, but I don't really have time to go into it. I'm happy to talk to you after. These trends are also being shown in marker capture. These are more intensive surveys, not just a single visit. The 5 you see are long-term 20-year studies where we actually mark frogs with bit tags. And then all these other ones are from the Cascades. You can see in California, this frog is declining pretty much everywhere. What happened with the fish when we stopped stocking these places? Well, we originally had 279 lakes. 90% of those were historically stocked. After our major change in policy, we found them present in 209 or 75% of those stocked lakes. And natural reproduction is occurring at least 84%. So most populations, by and large, are self-sustaining. And they're no longer present in 70 of those lakes, or 25%. But they also spread out into mini meadow systems, which are these unintended things. The fish came out of the lakes and they populated different areas. But look at the species composition. Historically, over 3/4 are brook trout, and they've gained ground, meaning the rainbows are a little more sensitive. Brook trout are just they're just self-sustaining. They've really capitalized on these habitats and do really well. Here's the distribution on the landscape. The blue dots are fish. Pay attention to the Russians. There's so many fish in the Russians. Every single lake has fish, except for a couple. But what I wanted to give you with this slide is so right now, what it represents is fish distribution is 89% of the combined lake surface area if we add them all up. But those 70 lakes where we don't have fish, it's only 11% of the combined surface area. What does that mean? Fish are disappearing in small lakes because the small lakes have winter and summer kill. What can we do about it? Well, we have 4 options. We have passive. We can maintain healthy, naturalized trout populations. These are ones that are persisting on their own no matter what we do. Some of these places haven't been stocked since the 70s, and brook trout are thriving. We can resume trout stocking in places where they might be important fisheries and people, fish them down, and we got to keep, replenishing them. Rainbow trout don't spawn in a lot of these places, so we might have to replenish them. This requires public input, but also we have some practical solutions using our data. We also we want to maintain currently fishless waters, and this is because the fish can't make it there in drought years. We really care about fish health. We don't think of the fish that are there as the demon. If we're going to manage them, we want them to be healthy and thriving. It's not a good place to put them if they blink out on their own. And then last, we want to actively remove trout in critical climate resilient areas that make a lot of sense, that aren't really important fisheries. Uh-oh. So what considerations do we have in this process? What's best for the fish? You can see some examples there. What's best for the angler? I'm treating these separately because we think about biology and then we think about the user. So we divide that out. What's best for the amphibians? And then what's best for removal situations in key habitats. To go about this, we got to have some initial screening. The methods we use are mechanical. We use geonets. If anybody has heard we've used poison in the mountain lakes to remove fish, that is wrong. We don't use rotenone in these places. It is a tool that's used in other places, but we have never used it. We use mechanical methods. So we start out, there's 311 lakes within the Cascades Frog Range. The current trout presence is 209 based off of our data. Feasibility for restoration, they have to be smaller than 3 hectares and less than 10 meters deep. That brings us down to 114 lakes. That leaves about 100 lakes that we can't even touch that have fish, that are going to have fish for who knows how long, and they're going to be fisheries. And then we put it through a multi-criteria decision analysis to decide on what lakes of those 114 are priority for restoration, and we want to come up with a list that we can use to make decisions. I'm not going into this today, but here is this process that we go through. The MCDA is used in wildlife resources for balancing finite resource use by multiple conflicting interest groups. You heard a lot about this yesterday with multiple talks. Ours is very simple. You first define the interest group, what we call intrinsic potential of that interest group. One of them is trout. The next is the Cascades frog. What's their intrinsic potential? The angler itself, that's and then the restoration intrinsic potential. So we take those 4 things. We have attributes, 3 attributes in each of those 4 that help score that intrinsic potential. And we use this weighted scoring for each lake, for each interest group, and then we combine them into these 2. Basically outputs. We have a site restoration score and we have a site fishery quality score. Those are 2 different competing interests, right? One on different ends of the spectrum. So you weigh the site you weigh frogs more by having them in a numerator, and then you weigh fish more by having them in a numerator, along with the angler, which isn't, you have to have fish survive. The angler isn't as important as having fish survive there. So we added less angler support. Anyways, it comes up with these separate values. When you plot them against each other, it's very fascinating. So on the x-axis is high-value restoration lakes. On the y-value is their score for final fishery quality. And you can see there's a high-value fisheries on the opposite end of the spectrum as a high-value restoration score. And here's where we have really good solutions in these places, where these are what we call steep and deeps. These are big, deep lakes that are cold. They take a long time to warm up. The frogs like to have shallow, warm waters for breeding. Whereas here, like I'm saying here, these are areas where the frogs benefit more, and they're less quality fisheries because they're smaller and they're shallower, and they may have fish kill. That's grainy. But anyways, here's the habitat. We have these scores, right? But we also want to think about where. A score is independent of a lake being on the landscape. You got to think about where on the landscape, and you can see here's Cascades frog distribution, what we know in the Klamaths, and here's the habitat on the left. So these 2 are kind of separate, but you can see there's areas where there's these gaps and there's strongholds. The dark red is the best habitat available for the frog, and it goes out to yellow, the worst. And then over here, you can see the same gaps are occurring. So you want to think about population structure, and where you do restoration matters, not just that NCDA score. So here's our 5 regions of focus. We got a grant to restore. These are another SWIG grant that's going to go through 2026. And we're currently working on 8 sites. You can see there it's kind of throughout the range. Here's the sites themselves. So you can see we have in the Scott watershed, we're working on Shadow, Long High, Wicks, and Middle Boulder Pond and Virginia Lake. In the Shasta watershed, we're working on Parks Creek and the Trinity River watershed, Bull Lake, Upper Deadfall Lake, and then Salmon Lake is we're going to start this summer. Just going through where we've been working, we started this restoration in 2023. I presented on it a little bit last year. These are these smaller lakes that, well, just to show you where this is, there it is. You can see there's tons of fish distribution in this region. And then where the frog icons are is where the frogs breed, which is a very important aspect of their life history is a breeding site, because that's where populations persist. So what we want to do here is we want to remove fish on this kind of edge of this area to connect the western marbles to the eastern marbles, at least have, connectivity so frogs can disperse. And over here at Long High, there's a lot of fish distribution out there, and there's very few frog options for breeding, and it's a really good site for possible frog breeding. Briefly, these graphs show catch per unit effort through time for trout, and then cumulative catch over time. Shadow Lake has a very small fish population, but it doesn't mean they're detrimental to frogs. It's just a small lake. We think we're winning there. That little bump is a cohort of young that are big enough to catch in a gill net. So you'll see that through these slides. Long High, we got a long way to go. Wildfires has been keeping us out of there. When a wildfire starts, we can't be within 15 air miles of a fire, which basically is really far. My regional manager is super conservative on being near fires, which is a good thing. Looking at the Russians and Northern Trinity Alps, here's Wicks Lake. We think last summer we made a good progress. We removed, we think we're going to probably finish that site this summer. If anybody's been to Wicks Lake, it's out there in the middle of nowhere. You got to go down a talus field to get to it. There's no trail, just on a shelf overlooking Scott Valley. It's a tiny lake. And that lake is on the edge of the northern Russians, which we want to keep that gene flow going north till it connects to the marbles. This area is what we think of as a frog stronghold. There's lots of frog distribution, and it connects the Russians with the Trinity Alps. Virginia is one of the biggest lakes we've taken on. You can see our catch is much greater there. But Middle Boulder Pond is a tiny little lake. You saw a picture of it earlier where the fish are snacking on frogs. We've pulled 1,000 fish out of that tiny pond the size of this room. Like, I don't know, they're coming from, I don't know, they're spring fed in there. But it's a tiny pond, not much, a few anglers may go there, but it's one of those like places that it's tiny and it doesn't get a ton of use. It's going to briefly go over this area. We have Parks Creek Lake. We're not there yet, but it's trending in good direction. Deadfall Lake, there was only a few fish in there. We think we've beat. We think we've gotten to the point where we can say it's fishless. Middle Deadfall Lake is a wonderful fishery down below. We're keeping that. You can see these fisheries are around these places we're restoring. Bull Lake is another one where it's part of that. There's not a lot of perennial habitat around it, so that one we have a long way to go. So the effort in broader context, we've started 8 lakes. We've only removed, this is 3.8% of the current 209 lakes with fish. This is only 1% of the surface area. But what we're doing really matters where we're doing it. These places really have high conservation value. Moving forward, we're going to maintain healthy trout populations in places that they don't get enough fishing pressure, and the brook trout are reproducing on their own, or rainbow trout in some cases. We don't need to stock them because it's going to put extra, they're going to basically starve the fish in some places. But there are popular lakes where we want to provide that resource. And because the frog is in status review right now, our policy is not allowing that, but we are going to restock after we get through this. We want to maintain all those current fishless waters because it's not healthy for the fish to put them there. We put fingerlings in the lakes. They have to grow up to become catchable size. It's not like we're throwing in lunkers that hit the frying pan. They have to grow up, but if they're dying, that's like a loss of, like, that's just throwing out taxpayer dollars just to get fish in a place they can't survive. So we're gonna keep those and count that as a win for restoration, but also a win for fish health. And then we want to remove fish at critical sites, which we're doing. But this is incremental. And we're taking on those 9 lakes that we currently have is keeping us plenty busy. Last, I just want to cover these fish are there for you to use. This is enjoyment of the public. We want to be very clear on where these fish are, and you have access to them. There is some confusion. Where are the fish? I went up there. There's no fish there, and we want to modernize people's resources. These are great fishing guides that were out from the 1960s. We thought about reproducing these trifold maps that people can carry. Not everybody wants an app, right? It gets overwhelming sometimes. But for those people, we do have an online resource for the whole state. You can go into these lake basins, it'll tell you what's there. I keep that modernized. And then we're building one for Region 1 of CDFW. I'm working with our GIS crew to use our data that we've collected. And this is a way fancier way to look at what species are where. This hasn't gone live. We're still building it, but I'm really excited about this because you can click on an individual lake. You can filter by species. Here's a lake, and it tells you when's the last time we saw fish. Are they breeding there? What species? Are there lunkers there? Did we catch lunkers? So that's a fun one to work on, and we hope to have that live sometime this year after we get management approval. I try to do as much outreach as possible because I don't want people to think we're out there like killing all the fish. We're not. We're basically righting the situation that when you stock 98% of surface area of lakes, that's a little extreme. We need to pull that back a little bit to be responsible. But we've talked to a lot of groups, and I'm always available to discuss. We don't contact wilderness users in the mountains, but we do. They often come to talk to us, and then we give them information because the wilderness experience is like some people just want to be left alone. But we make contact with hundreds of people that way by them coming to us. So that's all I have.
Yes, and the Sierras, is somebody doing the same type of work for the high mountain lakes?
I don't know. I'm pretty proud. We're like the cutting edge of this. As far as like the methods we're using to prioritize different things, we hope that our methods actually get expanded into places like the Sierra, where you have thousands of waters, or even Oregon and Washington, Idaho. This is not just a Klamath issue. It's widespread across the Western U.S.
And also, you're talking about Cascade frog and this
Yeah.
Are like the red-legged and yellow-legged frogs more adapted to fish than Cascades?
The yellow-leggeds are because they co-evolved in stream systems, definitely. The Cascades frogs are pretty naive to fish. The tadpoles just get pretty hammered in lakes. But if you have lake, they can coexist if the lake has shallow shorelines with emergent vegetation. It's like a fence, right? The fish, it's warmer, so it's like a desert for fish to go in there. So there's ways where not every, just because fish are there doesn't mean it's bad. I've seen plenty of cases where they can coexist. It's just you have to like find the right places and make sure you just understand the habitat that's available to the frogs. Yeah.
I have a question.
Yeah.
Have you found if one of the 3 trout species is more detrimental to the frogs? And are you focusing on removing one of the species?
Brook trout and brown trout are what we call them piscivorous salmonids. They prey on juvenile salmonids. Rainbow trout are more of an insect eater, right? We fish for them with flies, we don't fish for them with minnows or whatever. So brook trout generally and brown trout, they're more of the sharks in the water, and they readily prey on frogs. Rainbow trout, I think, are less impact because they tend to go for the bugs. But yeah.
Have you noticed similar patterns with long-toed salamander?
Yeah, Cascades frog, I just touched on them because they're under a microscope right now with the status review. There was a study the original study, and I've been counting all amphibians and reptiles. It's not just Cascades frogs. We have data for all species. But in that first round, they put a paper out that found that long-toed salamander larvae, which require to overwinter a year in lakes, and they live on the bottom in the deeper zones, not in the littoral zone. They were 44 more times likely to be found without fish than with fish, whereas Cascades frogs were 4 times as likely. So that's a huge magnitude difference. And I do think that long-toed salamanders are heavily impacted because they're in that zone where the trout cruise and they have to overwinter. Cascades frog larvae metamorphose in the fall. They're only there for like 3 months. So it is an issue, and they're pretty rare in lakes with fish. We rarely see them in lakes with fish. So we're going to analyze the long-toed salamander data as well, and everything we're doing here is benefiting that species and other species as well. We're just using the Cascades frog as an umbrella species to make decisions. Yep.
Regarding that habitat of the Cascade frog, when you showed the thing during the glacial age and all that, that I'll just say they migrated into the area. Are they still, is the area outside of where you're staying, is it still a stronghold? Are they doing well there, or are they getting hammered everywhere? Is it just the area?
They're doing far worse in the Cascades range. Where they came from like the McLeod area. There's like a little bridge of habitat, and then they're all the way down to Lassen Volcanic National Park, a little south of it. And we only have like 3 viable populations south of the park, and they're all isolated. They don't mix. It's a big meadows issue down there. It's not a trout issue. It's a loss of habitat and disease. So different issues. In the Klamath, we still have enough frogs that they can repopulate these places that we fix. But it's kind of shifting baselines, right? The habitat's drying more, their alternative habitat, the trout were in. But at the same time, trout have disappeared from 25% of the lakes. Like I said, like when I showed that graph that, they're declining some, but it's not like the drastic things we're seeing in the Cascades range where they're becoming really isolated. Yeah, it's just a lot drier in the Cascades too. We have, I don't know, a lot of Cascades frogs use a lot of meadow systems. They don't just use the lake. And we always say it takes a basin to raise a frog because they use all the habitats. They just need that lake when everything dries up. They're out in the streams during the summer, but they need to breed in ponds and lakes. So.
And this is the southern extent of the Cascade range, right? Because I think from on the maps, they're up in Oregon, Washington too.
They go all the way to the Canadian border into Cascades, and there's a disc chunk population in the Olympics, and there's a disc chunk population in the Klamath. So we share the Olympic kind of disc chunk, but they are truly, like that's their name, the Cascades frog, because they go all the way down to Lassen.
And is the northern populations doing better?
They are.
I just wanted, we talked about this over dinner last night, but so they are gonna stock like rainbow, you said?
Yeah.
And that will be by plane or by mule?
The horse packers are definitely interested in continuing. I think we've kind of been on a hiatus because, they can't stock the normal waters that they're used to stocking. Like we stock Kangaroo Lake every year because, you can drive there. There's you can handicap access, like it's a really important spot. And there's not a frog issue there, it's a steep and deep. So we just made that decision, we were gonna stock that place and, but the fish aren't gone, like you can tell, like, we still have 206 waters in that area that have fish, there's lots of opportunity. We only have 26 left to survey, and we've done the entire census, and like I said, updating those guides are gonna be very important for people to understand, okay, I can go here and I can go fishing. And we train our crews every year, like, to have alternatives known to the angler if they run into an angler and the angler really wants to fish at a lake, which is very rare because our lakes are really kind of isolated and off trail, a lot of them. But when they do, they say, hey, you can go over here and over here and over here. There's lots of opportunity around this. So
It sounds like they're gonna be still stocking some of the big robots.
they will, yes, we're gonna make it, we're taking all this data and all these MCDA analyses and we're gonna make decisions that are gonna affect the entire mountain range. And we're gonna include obviously our partners in that, like, kind of final, okay, this is a fishery, we're not gonna stock, we're gonna maintain it as a naturalized population, which as an angler myself, that's the one I'm gonna seek out because the fish are living, they're a product of the environment. Even though they're not native, they're actually like, they're there and they're doing, they're living within their means and what you catch there is a product of that system. As opposed to a stock fishery where it might be a really popular lake, Stoddard Lake, or, popular places up here where you need to like give it some augmentation.
Well,
And yeah,
the first lakes you were talking about, the fish taste a little better.
exactly. So yeah, I'd love input on where we should, anytime get a hold of me.
Thank you.